All right. Good morning, everyone, and thank you for joining us for another installment of the Long Coffee Break series. My name is Billy Donovan. I'm a sales engineer here in Long's Littleton office, and my co-host today is Vivek Chowdhury, and he'll be discussing why noise control is important for different HVAC applications. Vivek is a regional sales and application engineering manager with Vibroacoustics. He's definitely an expert in the field, and the Long team is very fortunate to have him and Vibroacoustics as partners. So with that, Vivek, I'll let you take it from here.
Thanks, Billy. Good morning, everybody. So today we're going to talk about noise control solution for different HVAC applications. Just to start, which projects should consider noise control? Most of the time we think projects like performing arts, studios, libraries, and churches are the main one. But actually all the other applications like healthcare facilities, educational facilities, school, colleges, universities, lab, data centers, residential, mixed-use building, every building needs some kind of a noise control. And the way vibroacoustics and Long building look into noise control is basically we look into the mechanical drawings from the consultants where all the equipments are located, starting from bigger equipments like rooftop units, cooling towers, chillers, and at the same time, smaller equipments like VAV boxes, terminal units, dampers, and diffusers. Based on the location and how the ductwork is running, we do analysis and we find out if there will be a noise issue down the road once the building is completed. And why do noise control problem exist? So basically it can happen due to three main reasons. The number one is noise control was never considered from the design stage. The number two will be post-design cost cutting. And number three will be the system components have been selected correctly, but were not integrated properly. And I'm going to talk more about that. The third point is the worst case scenario. Just to talk a little bit about value engineering is most of the time noise control is less than 1% of the mechanical budget. So if the project is over budget with a couple of $1 million, these days especially, is it worth the gamble? Probably not. And the main reason behind that is once the building have a noise issue, to fix that noise issue, it will cost 5 to 10 times of the initial cost. And the reason behind that is, for example, if we have silencers to redo and install the silencer again in the ductwork, we need to redo the whole ductwork again, just as one example. And what's the effective way to design noise control? So basically, we look into all the possible noise paths, starting from airborne, structure-borne, breakout, radiated, and flanking. Then we look into what are we trying to achieve? Are we dealing with NC criteria or DBA criteria? How much noise control is needed? Then we look into some project-specific requirement in terms of space, budget, material selection, etc. Based on all those factors and our analysis, we will provide a project-specific bid documents. In case we don't know what NC criteria or DBA criteria we should follow, we always reference ASHRAE as the basic guidelines. We are doing this noise control solution for the last 60 years, and we have identified 14 different noise paths from which noise can travel through from the equipment into the occupied space. Just to talk about some common problems. The number one common problem is pressure drop. So basically, the way vibroacoustics and Long look into the pressure drop is we differentiate between the idle pressure drop, or we call it a catalog pressure drop, versus the system effect pressure drop. And to define that, the idle pressure drop, every single noise control manufacturer follow ASTM E477 testing requirements. So we have a lab here in Toronto, Canada, where we do all the testing. And based on this ASTM E477 testing requirements, we have to leave 5 dia of straight duct at the silencer inlet and 10 dia of straight duct at the silencer outlet. So whenever you see a noise control manufacturer showing the pressure drop, it will always be the idle pressure drop, and that's how it is calculated in the labs. So which means if we are testing a 5-footer silencer, we are having 20 to 25 feet of straight duct, which we normally do not see on the mechanical drawings. That's why it's very important to look into the system effect pressure drop. And that's why whenever we provide the schedule on the silencer, we always show two pressure drop. One is idle pressure drop and second is system effect pressure drop. And we do provide all the calculations to stand behind it in terms of pressure drop and acoustical calculations as well. So always look into pressure drop with system effect on your submittals. And now I want to talk about the common problem number 2, which is breakout noise issue. And to explain that, let's assume we have a air handling unit in this mechanical room, which is creating noise to this occupied space. So these 3 yellow boxes are 3-stage silencer we have in every single branch to mitigate the noise. But we will still have the noise issue because we are having the noise source in this case is this air handling unit, which is creating the noise issue in this area, which is called as a breakout noise issue. So basically the noise is breaking out from the duct itself going into this occupied space. To control that, we will actually need this T-shaped silencer, which is going to take care of both the airborne noise and the breakout noise, which will also serve as a T-shaped duct and will have a better performance and better pressure drop with system effect. Sometime based on our analysis, we will recommend a T-shaped silencer or any other silencer with a HTL casing to control the breakout noise. And HTL casing is a high transmission loss casing, which is basically a thicker casing on the outside of the silencer to make sure that noise is not going to bypass the casing itself. So breakout is the most common noise problem in HVAC system, and the reasons behind that is lightweight room construction, the air handling unit located above the occupied space, higher sound power data of the equipment, and the occupied spaces near the mechanical room. And how to deal with the breakout noise, we will always look into what type of space is affected, and the calculation is always needed to first of all calculate to see will there be a breakout noise issue, and if there is, how much. And the location of the silencer plays a very critical role. And then based on the calculation, we also find out, do we need a HTL casing or we don't? So the way of vibroacoustics in long building to combine the acoustical and system analysis and become your product expert. In case there are acoustical consultant involved on the project, we will request you to send your long representative, the acoustical consultant report, which normally talks about the NC criteria, DBA criteria, or the performance required. And then we will request how much pressure drop is allowed, how much space is allowed. The goal is to try to make a combination of acoustical analysis and system analysis and provide a solution to you which makes sense from both point of view. In case there is no acoustical consultant, yes, we can do the analysis for you and act as a product expert for you on the acoustical side of that particular project. On the solution side, we do have different solutions, not just silencers. We have acoustical barrier, enclosures, acoustical louvers, and integrated acoustical curbs as well. And you can see the pictures, we can do different types of the configuration for the silencers as well. Now I want to talk about some application-specific solutions. The first one is the rooftop units. So if we have a rooftop unit located right above the occupied space, there will be some benefits of that. The first of all is energy efficient, the building cost, space-saving design, and time-saving design, with the only problem, which is going to be the noise problem and client complaints. So for those specific cases, when we have this rooftop unit right above occupied space, like a conference room, or office room, classroom, hospital application, we have identified these are the different 14 noise paths from which noise can actually travel through from the equipment into the occupied space. And to control all of these noise paths and the noise, we have this solution, we call it an integrated noise control curb solution, which is basically a package solution of vibration isolation curb, acoustical barrier, and a supply and return silencer. Vibroacoustics and Long will provide end result guarantee solution, and we do provide PE stamp calculation in terms of pressure drop, acoustical calculation, and even wind and seismic rated calculation if that is required. So this is a really nice solution when we are concerned about the noise traveling from the equipment right below. These are some of the pictures, how they look like once they are installed. So from outside, they look like any other vibration isolation curve. And this is how the schedule will be sent out from your local long representative, talking about the rooftop unit tags, the type of the model, which is NCC VCR, what NC criteria we are able to meet. So RTU1, we are able to meet NC30, RTU9, we're able to meet NC25. And all these are the calculation we are going to provide. This is not a flat spec solution. Every other noise control manufacturer can provide the solution as well, but we want to make sure it's an apple to apple comparison, and they are also providing the same calculations as we are. The next I want to talk about is generator noise issue. For generators, we do have different kind of solution depending on what are we trying to achieve and how much space we have. The easiest solution will be elbow silencer for some tight spaces. We do acoustical line plenums as well, intake and discharge silencers, acoustical louvers. The picture on the right is acoustical louver, and the color was picked up by the architect to match the building color. We also do full generator enclosure and work with the generator manufacturers to make sure we are not voiding out any warranties. There are some challenges with the generator noise. The main one is the pressure drop, the space, and these are loud equipment. So we are trying to mitigate the noise a lot. This is one of the nice projects we work on called Philadelphia Data Center. The project was completed, and the neighbors made a complaint regarding the noise coming out from the building. We looked into this from our local rep in Philadelphia, and we saw there is not much space there on the job. And we were able to find out is a transitional duct, basically. And what we did is we converted the transitional duct into the transitional silencer, and we were able to mitigate the noise quite significantly. So we can also do different applications and provide different solution. In case you have a project, please send it to your local long representative. All we need is the mechanical drawings showing the ductwork and the equipment cut sheets, and we'll be able to do a quick analysis for you. We call it a design assist engineering lane service. We don't charge anything for that, and able to provide you if will there be a noise issue or not. That's it from my side. Thank you, everybody. Over to you, Billy.
Thank you all for coming again, and have a happy Thanksgiving.